Hello, this is my 14th video in my series on using Google Sheets to do inferential statistics by simulation in a way that's hopefully more intuitive than just using tests to find p-values. This is the final little series of videos, I hope. This one is on numerical data when both the input variable and the output variable are numerical. Now, we've done a series like this before for paired numerical data, videos 5, 6, 7, and 8. But in that case, we were looking at simply, is there any difference at all between the first variable and the second variable? Here, we're going to ask a slightly different question. What is the relationship between them? In other words, we're going to do a correlation and determine if that correlation is statistically significant. For this first video, we're just going to scrub the data. I'm going to make a new spreadsheet over here to play with. This is the June 2018 Pulse of the Nation survey from the good folks at Cards Against Humanity. We're going to look at our input variable. Our independent variable is what people's income is. So I'm going to copy that over to this sheet. And as always, I'm going to view, freeze one row. And our output variable is going to be what they think the tax rate should be on people making over $500,000 a year. One would think that people making more money would want a lower tax rate on the top end of their income, but let's see if that's true. First thing I want to do to scrub the data, I want to do, again, view, freeze one row, column A. I'm going to sort sheet A to Z. And I'm going to find the values that don't make any sense. Sure, this person might be making $1,000 a year. They might be a college student or somebody whose spouse makes all the money. Let's scroll down to the bottom here. I'll buy that, $850,000 a year. Much more than that, I'd have a question mark. But then I have all these people who didn't answer at all. Click on the first one, scroll down to the end, hold shift, click anywhere here, right click, and delete all those rows. Now I want to do the same thing for tax rate, sort sheet A to Z. I have a bunch of people who didn't answer at all. And this person who thinks the tax rate should be 10,000%, 100,000%, which doesn't make any sense. They also said they made $100,000 a year. I kind of suspect that person was just saying 100,000 as a response to everything. Again, delete all those rows that don't make any sense. Now we have answers from a top tax rate of 90% all the way down to 1%, and our data are scrubbed. Now we're going to make a little graph of this data. So I'm going to highlight both of these columns. I'm going to go Insert, Chart, and it gives me this. Oh, it gave me a scatter plot to begin with. Sometimes it doesn't. If it doesn't give you a scatter plot to start with, under Chart Type, I can select a scatter plot down here in case it doesn't give me one to begin with, but it gave me one to begin with I'm happy with. If I want to go ahead and get the linear regression or any other regression for that matter, I'm going to go to Customize, Series, and one of my options here is Trend Line. There's my linear regression. I would like to label it with the equation for the trend line. There's my equation. And I'd like to go ahead and show the R squared, which is called the correlation coefficient. So this is telling me that this 25.6 is somebody with no income, thinks the top tax rate should be 25.6. This slope tells me each dollar more you make, you want the tax rate to rise by 0.0000162%. And this R squared tells me that 0.008, less than 1% of the variation in people's answer for the tax rate can be explained by their income, which is not very much. Income does not do a very good job of explaining the tax rate. And what's more, it's sort of the opposite of what you might think. The more money you make, the higher you think the tax rate should be, not the lower. In the next couple of videos, we're going to see if that is a statistically significant correlation.